comma, 0. Yep. So this would be the B, yes. It can't just because of the way that it wants you to label it. So you see how it says the hypotenuse had to be labeled as AB? That's why I had to label it as AB.
Because you can still have CB.
Oh, you mean this?
Yeah.
But then it wouldn't have CB.
Wouldn't CB just be up top?
Oh yeah, you can still have CB.
Like, I just wanted.
Let's see, hold on.
If you switched A and
If
B,
we
you could
switched
still
A
have
and B and we did BA, that would mean half of AC's. Yeah, I mean, it would probably be okay. If I looked at it all and it all made sense, you just switched the B and the A, you'd still have similar coordinates. You just maybe would have this switched with this one. Lindsay, right? You just switch these two. That should be okay. Okay? That's a good question. Number 8, similar here. So, again.
Turn from one.
See if it's still recording. Yep. Okay. It says 2. Yeah, you're gonna see my face go really close. All right, 2 of the vertices of an equilateral triangle are. Does that say 0B? You guys have a hole through it too. I think that's supposed to say 0B. Okay, are 0B. Oh, and 0B.
0 negative B.
Ah, that's
See,
what it's
there's a
supposed to
little
say.
dot.
Oh, good. Thank you. Okay, so 2 of the vertices of an equilateral triangle are 0, negative B, and 0B. Third vertex is on the x-axis to the right of the origin. Okay, so if we think about this for a second, I don't think we can put the whole triangle in the first quadrant because, look, one of them has a negative B as the y. So this is going to be looking like this. Okay, because we have to have a negative B and a positive B for y. So that means it has to be on both the y-axis, both sides of the y-axis. Then it says the third vertex is on the x-axis to the right of the origin. I'm just following the directions here. So if these are our 2 coordinates here, that means this one has to be 0B. This one has to be 0, negative B.
She's writing it so different.
I know, right?
I don't see why this would be much different. This is a different?
Yeah.
You can't really have much different than this.
I did like, I did
Because
that.
they were really specific.
I did
Like, you
that.
couldn't really do much different than that because it said to the right of the origin and it has to be, so it has to really look like this. Now, what would be this vertex? There.
Why is it in the one possible quadrant?
It has to be based on the 2 vertices that it gave us. We have a negative y, so there's no way that we can do, it has to be here.
There's no negative.
Yes, negative. It's hard to see, Lindsay. There's a hole punched through it. But one of the triangle vertices it says is 0, negative b.
That's a 0, 0.
Yeah, that's hard to tell. That's why it's different, Lindsay. Yeah. That was my fault, Lindsay. That's not your fault. Okay, so it was supposed to be 0, negative b, so it's kind of hard. Okay? So now with this information though, what would we do to get the third vertex? What would x have to be? Actually, no, not x. What would y have to be? 0. Okay, what would we do? Y? What? Why would it not be 0 if it's on the x-axis, right? Okay, then what would this be? That's a good point. Okay, listen to what Aiden said. He said b, comma, 0. Why could it not be b? Because we already used B for Y. So let's say, what would be the other letter that they used? A. That's really it. Just use A or B. To make it easy on yourself, it's either going to be A or B, really. Okay? Or 0. They did, yeah, they switched the axis on us, I know. But this would be what you would do here. Yes. A is usually the x-axis, but really, if whatever they label it as, you just do, if it's the y-axis as B, you do the x-axis A. If it's the x-axis B, then you do the y-axis A. Okay, so.
If you're using correctly, do you just draw a random triangle?
Yeah, really. You don't have to worry about what the actual lengths are, you know, it really is random, yeah.
Like, could you take the triangle in the first quadrant and draw a triangle like that?
Like this? This part?
No, if you, like, show her what you do.
No. Oh my gosh.
Well, you might have done yours, though, based on this being 0, 0,
Yeah.
right? Or just 0, 0. So this is going to be more like what you'd see. I would focus more on this kind of thing than that one. Because, like I said, this will be very similar to your quiz. I can't stress that enough. Okay? It's very, very similar. Okay? All right. Now, the last one, I think we all kind of gave up because we saw coordinate proof. But please don't give up. I put this on here because it's very easy. Okay? Yes, it's more work, but it's very easy. Okay? So what does it say? For questions 9 and 10, complete the coordinate proof. Really, just ignore what that says. Okay? Really, what you need to focus on is at the bottom. It says, by the distance formula, the lengths of the 3 sides are as follows. Find the distance of one side. Find the distance of the other side. That's it. You just need to find the distance of the 3 sides. Okay, I didn't put three lengths there. But you just need to find the distance of one side of the triangle, the second side of the triangle, the third side of the triangle. And then, if you found the distances, you can determine whether it's isosceles or not. So, you don't even need to say it's isosceles or not. Just find the distances 3 times. That's all. Okay? So that's what the problem on your quiz is going to look like. You just need to find the distances of the 3 sides. So, distance formula, we'll review. These are our 3 sides, our 3 coordinates. And it makes up DEF. If I'm finding the distance of all 3 sides, I'm just going to do it DE, EF, DF. Okay, and those are going to be my 3 different distances. Now, how do we do the distance formula? Anybody?
X2 minus X1.
Okay, so our x coordinates is what you need to know, squared,
Yeah, plus Y2
plus our y coordinates subtracted, squared. Okay, you need to know this. So, if we're going to do DE, we have 5 minus 2 squared and 4 minus 1 squared. This is, you can use your notes, but not your study guide. Okay, so DE equals that. So, we just solved 5 minus 2 squared. Okay, you can't tell me that you didn't know what to do on this one if you're not paying attention. 4 minus 1 is 3 again, squared. So we have 9 plus 9. And we have to do the square root of it. So 18. Now, you can just leave it as 18, square root of 18. That's fine. Okay? Now, do I need to do EF and DF? Or do we know the point? Okay? We know the point. Yeah, they're well, whatever they're equal to, if they should have at least 2 of the sides equal because it says it's isosceles. So that could help you check yourself too, to make sure you're doing it correctly. But yeah, so at least one of them probably should be the same as this one. But it's really just using the distance formula. So, any questions? Any other questions? Final questions? Anything else from the video? The study guide.
There's something from Anita.
Okay, so I'm gonna turn off the video then. Now,